So today we talk about the Kubernetes objects. Okay, so we have a lot of Kubernetes objects like pod, replica set, daemon set, deployment, job, secrets, config maps, volumes, like this. Lot of objects are available inside that. So today we are going to discuss about the pod and the deployments, how we will deploy the applications, how many types of deployment types will be there, how we can deploy our application. Okay, so like replica set, daemon set, stateful set, and deployment. So these are the things we are going to discuss. And first, as all of you know, in Kubernetes, we'll use the manifest file. And for this manifest file, Kubernetes uses YAML. Okay, so there will be like multiple markup languages are there, like XML. Like these are the like formats. Okay, syntax will be there. This is not a programming language like if you see XML format or HTML format or maybe JSON format. These are a file formats. The syntaxes will be there. Each file syntaxes will be different. Okay, so same way YAML is also one of the markup language. Some people will tell that okay, it's yet another markup language, the full form of YAML, or some people will argue it's not a markup language. So this is also syntax, but compared to JSON, XML, HTML, YAML is very easy to write, okay, and easy to understand also. Just it will be like a key value pair. Okay, key will be there and the value will be there. It will be very easy, okay, to understand. We no need to have any high skills to understand this. Like it will be difficult to understand JSON format or maybe XML, but understanding YAML file or writing this manifest file in the YAML format, it will be very easy. So to create any object inside the Kubernetes, we use manifest files, okay, with the help of YAML. So here, whenever we trying to create any object by using this YAML file, four things we need to understand here inside the YAML file, which are very important. So the first one is API version. Okay, so API version, and second one is kind, and third one is metadata, and fourth one is spec. These are the four things are important whenever you are writing, creating any YAML file. So what is this API version? The API version defines the version number which this object belongs to. Okay. So what are the object you are going to create? See, whenever the Kubernetes was developing that object, they are going to use some version to that object. Okay. See, when they started Kubernetes, initially they might be started pod, the first concept. After that, they implemented another object called replica set, daemon set. Like what are the objects we have right now in the Kubernetes? So initially, maybe starting only few objects was using. Okay, slowly one by one, they might be introducing new objects. So whenever they was introducing the object, before it comes to the stable version, they will give the API version as an something like this one, alpha. Okay, V beta, something like this. Okay, let me If you see for this one of the kind is deployment. If you see this is a apps v1. Okay, so the deployment kind is belongs to this version. Okay, so here basically we'll get some, and here you can see these are the four fields what I was talking about. Which version of the Kubernetes API you are using to create this object, and kind, what kind of object you want to create. Okay, so kind in the sense what object you are creating, whether you are creating a pod, are you creating any network service, are you creating any volume, are you creating any job, or are you creating any secrets, config maps. So kind will decide what is it, the object. Okay, and metadata. So data that helps uniquely identifying the object, including a name, string, okay, labels, what name you are giving to you this object while you are creating. Let's say you are creating a pod. So kind is pod, and what is the name you are going to give to that pod? Are you giving any labels to that pod? So those information will come into the metadata. And specs, what state you desire for that object. If it is a pod, then you can decide how much resources you are giving, what is the name of the container you want it to be, any commands you want to execute after the container, the pod has been created. This kind of specifications you can give. So it depends upon the object, what kind of object you are creating. Based on that, the specifications will be available. So regarding this API, we are not getting the proper document. These Kubernetes documents also will be keep on changing. They will not be the same always. If you see here, based upon the kind, you can see this API versions. Okay, so if you see here for cluster role, this is an API version. Cluster role binding, this is an version, and config map, this is a version. Okay, and for all these kinds, okay, we have different versions, and we'll get the sample example of each and every object to create. We'll get the YAML file from the Kubernetes document itself. We can take it from there. Okay, so what is this API versions? Alpha versions with alpha in their name are early candidates for new functionality coming into Kubernetes. This may contain bugs and are not guaranteed to work in the future. Means whatever the objects is having alpha, which means that it is not yet fully tested. It's not come into the stable version, that object. So for example, Kubernetes introduced one new object. Okay, they are doing testing, so they will give you that object to use. But to create that object, obviously in the YAML file, if it is mentioned that it's an alpha as an API version, then you can use it, but it is not guaranteed that it is going to function properly. It might have some bugs also. Okay, and if it contains beta in API version may means that the testing has progressed past alpha level, and that the feature will eventually be included in Kubernetes. Although the way it works might change and the way objects are defined may change completely. So beta means, right, beta versions. Even in operating systems also we'll get the some beta versions. Okay, and then we'll get full version. Same here. So this next step of alpha, that particular object is tested but not fully came to the market to use it. And stable, this do not contain alpha or beta in their name. They are safe to use. So stable, when it becomes stable, then we can use. So in your organization also, whenever let's say you got opportunity to work on Kubernetes and you want to implement few things and you want to create any object, and that object is not yet fully stable, then don't recommend in your organization. And even if you're recommending, then you need to define, okay, you need to mention that this is not a stable version, but this feature we can use in a development environment. If this works fine, then we can use it later on after it becomes a stable version. Okay, so apart from that, so this will be like a stable version. This was the first stable release of the Kubernetes. Means when Kubernetes started at that time, what are the objects they were created at that time for those components or objects we're using API version is V1. Okay. Now this apps I slash V1 will be used for most of the objects, even for deployment or services volumes, we'll use this one. So apps is the most common API group in Kubernetes with many core objects being drawn from it, and even it includes functionality related to running applications. So most of the objects we use, the API version is apps one only. We cannot decide that object will be decided which if you give wrong API version, it will not work. For example, instead of this one, for one of the object by default it is this this API version is there. If you change and put something like alpha beta to that object, it will not get created. Okay, so most of the objects we use, this is an API version, and this is an auto scaling batch one beta. You can see for a few of the objects for these kind of versions, but we can ignore that. So majorly it will be this one. Okay, 90% of the objects will be using this one. Okay, so this is about the API version. And kind already we discussed. Kind is what object you are going to create. That is an object. And metadata, um, as I said, under which namespace should be created. What is the name of this whatever the kind you are going to use. For example, if you're using pod, then what is the name of that pod? All these things you can define. And specifications, it depends upon the kind. If we take example of pod, then what is the container name? If you want to execute any command, all these things will come under this specific specifications. Okay, and this one batch, we have a batch jobs also inside the Kubernetes. For that, it will use batch slash v1. Okay, so jobs will be there in the Kubernetes. That is also we'll discuss later on what is job. So for that it will use batch slash v1. So now we'll talk about the first component is called pod. Okay. So what is a pod? So pod is a multi-container. Okay, in a pod. So you will have multi-container in a pod, and pod contains networking. That is also important, and interpod and intrapod communication, pod life cycle. So these are the things we need to understand whenever we talk about a pod. So already we discussed what is a pod. So pod is a wrapper, okay, on a container. So for a container it will be a wrapper, and on top of that it will have the uh, pod. It's like a atomic unit of scheduling. So in virtual world, if you want to deploy any application, we'll deploy it in a VM, right? In a, till now, before cloud comes into the picture, or even in cloud also, if you create a instance or virtual machine, it's a virtual machine. Backend physical hardware is maintaining by some other organization. So in Docker world, okay, we use container. The same thing is in the Docker, we use container. The difference also we discussed in the Docker sessions, okay. But in Kubernetes, we use pod, okay. So basically, we call it as a scheduling unit. So to deploy the pod, we need a manifest file which contains container images, same like Docker only. So here, so if these are the worker nodes are available, assume these are the two worker nodes are available, and the pod, let's say, so to deploy the pod, we need a manifest file. So we are going to have manifest file with basic features, and the pod to create it, it will get created, and it will pull the image wherever the source location you are giving the repository. From there, it will pull the image and it will create. Okay. Now, as we discussed, the whenever you are creating, let's say if I'm executing a command called kubectl create -f pod.yaml, means this YAML file have the specifications, the pod creation manifest file. When execute this, it will send request to the API, the master API server, and from there it will send it to the scheduler. Scheduler will go and deploy the pod into the worker node, whichever the worker node it defines. So now, so Kubernetes will not directly deploy containers on worker node. Instead, containers are encapsulated inside a pod. Okay. So what it will do? It will create a container. On top of that, it will be layer called, in the Kubernetes terminology, it will be a layer. Okay, and that's like a wrapper on a container. So why we don't have direct container here? Because here we have a concept of multi-container pod. Okay, so that's why we have a wrapper called pod, and inside that it can be having multi-container pod. Okay, so why we, as already we discussed, why we need to have multi containers inside a pod. Okay, why? Because as I said, sometimes there will be a some other container should be also available inside a pod. Okay, so that's the reason we have a concept called pod, so that multiple containers can run inside a pod. So here it can be to pull the log files of this. One of the example is pull the log files of this application, and this container will help to pull the log files of this application, and this container will send that information to the different resources like Elasticsearch or Prometheus. Okay, so it will take that information, it will send it to that. In that scenario, it need multiple containers. Okay, so
Sorry,
now if it, yeah,
like how many deployments or how many applications can we have in single pod?
how many?
How many applications can we deploy into a single pod since we have multiple containers in one
Hmm.
pod?
Hmm.
Since we have multiple container in one pod, then how many applications can be deployed into a single pod?
See, if you want, you can have multiple applications also, but at a time you can access only the single application. And here you should not install or deploy multiple applications in a single pod. So it should be a separate pod for every application, because if the pod is down, then your multiple applications will be down. That is not our agenda, right? So for every, for example, if your application is microservice, which divided into the microservice, and you have, for example, 15 microservices. For 15 microservices, it should have separate pod. That is the purpose of microservice, and that is the purpose of containerization. Why? Because if I want to do any R&D, or if I want to upgrade my specific microservice, then I will upgrade that application, and I will again redeployed. If both the microservices or multiple microservices are a single pod, then if you are upgrading your microservice, then it will impact the other microservice which is inside that pod, right? So we don't deploy multiple microservices or multiple applications in a single pod. Again, it's like a VM only, right? All your applications running on a single VM. So there is no advantage of having containers here. Why we are using containers? The microservices can be deployed into different containers or pods, so that if even single application is not working, it doesn't impact the complete app. So that's why we are dividing it as a microservice and deploying it as in a pods. So it's not recommended to have multiple applications in a single pod. You can do that, but there is no use. It's a lot of disadvantages. Okay.
So, so in your example, Praveen, let us suppose 15
Mm.
microservices are there. So
Mm.
15 pods we deploy, and each pod will have one container for one microservice,
Yes.
plus some other log collections, log collectors or something in each pod.
If that you define, if
Yeah.
that you define inside your pod, then it will be created. If you don't define second container specifications inside your pod manifest file, then it will not get created. Only application pod will get created, application container will get created. That's it.
So in a specific pod is killed, down or not responding, we can kill and we can spin up another pod, right?
Yes, that will be done by the Kubernetes itself automatically. So
Okay.
if it is not working, it will try to restart it multiple times. And if it is working, then it's okay. Okay.
Also, let us suppose billing, ordering, and each pod we have it for each microservice. But whereas for payments, which is a very critical service and high activity will takes place on the payments. So can we have multiple pods for payments and one single microservice for one pod
Yes,
for the rest of the
yes,
everything? Okay,
yeah, that is
that based on
possible.
the design. Okay,
Yeah.
okay, gotcha.
So in the pod, another thing we need to understand is pod networking. Okay, we are talking about pod. So
Hmm.
if multiple containers are residing inside a pod, then how it is communicating, how those pods will communicate, like how internal containers will communicate, and how the pod networking is going to happen. We'll see. Okay, pod. So here, so a pod encapsulates an application's container, or in some cases, multiple containers, storage resources, unique network identity, IP address, as well as options that govern how to connect. And a pod represents a unity deployment, a single instance of an application which might consist of either a single container or a small number of containers. So pod that runs a single container, the one container per pod model is the most common Kubernetes use case. Maximum will use single container, single pod only. In this case, you can think of a pod as a wrapper around a single container, and Kubernetes manages the pod rather than the containers directly. Pod that run multiple containers that need to work together. A pod might encapsulate an application composed of multiple co-located containers that are tightly coupled and need to share resources. So these co-located containers might form a single cohesive unit of service, one container serving files from a shared volume to the public, while a separate sidecar container refreshes or updates those files. As I said, we'll use sidecar container to get the logs of that application. So sometimes we use sidecar container, should be deployed in along with your application. So it will get the logs, and that sidecar container will send the logs to the uh, Elasticsearch or Prometheus. Okay, so how pod we can have this like detailed information. You can go through this detailed information. So I just specifically want to discuss about the networking. So each pod is assigned a unique IP address. So here, whenever you deploy, if you remember, uh, when I was using bare metal Kubernetes cluster, I executed a file called calico.yaml file. In that, I specifically discussed 192.168.0.0/16, right? So that is a pod network, means every pod is going to get that IP range. So unique IP is going to get for every pod. So let's say 192.168.1.15, something like this, and another pod is going to get 192.168.1.16. So every pod is going to get. So if you want to access the pod, okay, then you can able to access it by using this IP address. Okay, so every container in a pod shares the network namespace. So here inside this pod there is a concept called namespace. Okay, so it is going to use that namespace including the IP address and network ports. So containers inside a pod can communicate with another using localhost. Let's say if two containers are there, so here containers doesn't have any IPs here. They will communicate with the local host. And let's say this container is having 8080 and this container is having 8081 port number. With that port number, they can able to access. So internally, they can able to access with the local host concept. Okay. So when containers in a pod communicate with entities outside the pod, they must coordinate how they use the shared network resources, such as ports. So as I said, if this is an 8081 and this is an 8080, then with the IP of this pod you can able to access 192.168.1.15 8080, and same way this way you can communicate if you want with multiple containers from outside. Inside they will access with the localhost because they use the network namespace inside that, so that's why they can able to communicate. And if you allocate a volume to this pod, then it will be accessed by both the containers inside the pod. The pod can specify a set of shared storage volumes. All containers in the pod can access the shared volumes, allowing those containers to share data. Volumes also allow persistent data in a pod to survive in case one of the containers within needs to be restarted. Okay, so this is how you can go in detail about this if you have time, then how it will work. So now what I'm going to do, so yeah, one more thing I will need to discuss. Interpod. So what is interpod? So interpod means how a pod will communicate with the another pod. So here this is one pod and this is another pod. We discussed about internally how it communicated, but this pod how it will communicate. Interpod, all the pod IP addresses, okay, are fully routable. Why? Because we executed that calico.yaml file, right? So with the help of that calico and kubeproxy concept, so it is going to configure the routable. So if you have multiple worker nodes and you have, let's say, pods has been created, so there will be a network will be there. So here routable network will be there. Okay, so you can able to communicate each other from this pod to this pod. This is one worker node, from here to here, here to here they will communicate because that calico network has been configured. Okay, so that's the reason they can able to communicate. So here whatever the calico network I used, if you remember, let me show you that one. So when I was deploying the Kubernetes cluster through, this is the KubeADM concept, right? So in the KubeADM concept, so this was the network, okay? So Calico network, but the same will be not used by the different clusters, okay? I created GKE cluster. We may create Azure cluster or EKS. Different cluster concepts are there. So every time it may not use Calico. If you are using KubeADM concept, then you can use Calico, or maybe you can use a flannel network is also available. I will show you different types of uh, network plugins. Hmm. Okay, if you see, these are the network plugins: ACI and Andrea, AOS, AWS VPC, CNA for Kubernetes, and Azure CNA. In case if you are using Azure Cloud to create Kubernetes cluster, the AKS, then internal it will use Azure CNA is an open source plugin that integrates Kubernetes pods with an Azure virtual network. So what it will do, this Azure CNA, whatever the, because in Azure you are going to create VPC subnets, right? So whatever the machines Kubernetes gets created, so this Azure CNA will be able to communicate with that internal network. So this is a separate network plugin it will use. It will not use Calico. Okay, and this big cloud fabric from Big Switch Networks, Cilium, and CNA Jenny from Hawaii, and these many. See the flannel. Previously we used to use this flannel plugin when we are using a KubeADM concept. Flannel is a very simple overlay network that satisfies the Kubernetes requirements. Many people have reported success with Flannel and Kubernetes. Okay, instead of Calico, previously I was using Flannel. Okay, now I'm using Calico. So now Google Compute Engine here, if you see for the Google Compute Engine cluster counting scripts, advanced routing is used to as an each VMS subnet. So this is using separate this one. Okay, plugin, and Jaguar, K-Switch, Knitter. In Knitter, sometimes they'll ask you name some of the which they'll ask you which Knitter plugin you are using in your environment, and what are the other plugins you know, why we are not using those plugins. This kind of questions they will ask you. Okay, Open Switch. This is a Calico. An open source container network plugin and network policy engine. Calico provides highly scalable networking and network policy solution for connecting Kubernetes pods based on the same IP networking principles as the internet. Okay, so with the help of this, it is you can able to communicate, because this is going to create a network layer so that it's routable also. So you can able to access the pods from here to here, here to here. All this will be the same cluster, and they can able to communicate. And intrapod means already we discussed. Okay, so this is an interpod, and intrapod means inside the pod. So two containers, how they will communicate inside a pod. Okay, so that we already discussed. So it will use the localhost interface. So with that help of localhost interface, they can able to communicate directly with each other with their ports, whatever they are using. Okay, now we'll try to create a pod. In the meantime, let me power on my cluster. So as of now, I'm using AWS cluster itself, means whatever we used for KubeADM. Okay, because on that day again immediately I deleted that GK cluster. Then later on again we can use it for the simple creating pods. We don't need GK also. So executing the commands, creating the objects is same, whether it's a GKE or whether it's a bare metal Kubernetes, concept is same. Only how we are accessing it, that will make the difference. And little bit, as I said, the networking plugin is different. Apart from that, creating objects will be the same.
Praveen,
Yes.
if you create a pod, only pod will get IP, right? Container won't get any IP.
Yes, container will not get any IP.
Okay, fine. And if you want to troubleshoot any container, how we will log into the container in such case?
I will show you. I'll try to create a pod with two containers, and then I will show. Only very simple thing is you need to give -c and the container name to the command, like to log into the pod.
Yeah, okay. Thank you, bro.
So let me connect to the master. So now we'll get the YAML file. Okay, so we can get it from our own Kubernetes document itself. Okay, so let me copy this one. This is a YAML file and this is an API version V1. Why? Because it's as we discussed, V1 is a very old API version. Means when Kubernetes has been introduced, this is the first concept pod was introduced, the kind. So that's why they were using V1. For latest objects, we'll get apps/V1 as an API version, which means it is an the latest objects has been introduced by the Kubernetes. So this is an YAML file we can take. If you see, this is an API version, and the kind is a pod we are creating, and metadata, the name of this pod we are giving, and labels, we can give labels. Okay, like if hundreds of pods are getting created, we can label, for example, application name. So what are the application name? For specific application, 10 pods are creating. Then if I want to filter those 10 pods, then I can give the labels. So I can filter while I'm want to view that information of those 10 pods. With the labels, I can able to filter that. So that's why we give labels. And spec field, so this field contains the specifications. So here you will decide how many containers you want to create. And if it is a single container, then what is the name of that container? and what is the where is the image location. You need to give the image location, and this we'll discuss about this specifications. Image pull policy means what? It will go and check the image in the remote repository, and from there it will pull the image and will container will be get created. So if not present means, if not present, then only it will pull the image. If already present, then it will not pull the image. Okay, so this is, you can ignore as of now. We'll have like in separate session I will discuss. Node selector means nothing but um, on specific node you want to create the pod. Okay, so or else in this machine I should have mm, okay, if I see. So if we see, this is the one. Whatever it may be. So let me create. So kubectl create -f pod dot YAML. This way we can able to create. So it is created, and if you check kubectl get pods, see this is a pod is getting created with this name. So this is the name of this pod we defined, and it's ready and running. So this one by one means ready and running state, and restarts means, as I said, if any issue comes, then Kubernetes, the kubelet component which is there, will try to restart your pod. Okay, and 4 seconds ago it got created, and kubectl get pods -o wide. If you give, then it will give you the IP address of this pod whatever is assigned, and on which node it got deployed also it will define. So this is how we can get it, and this is a pod IP address. And actually I'm looking for Nginx. We'll see whether this will get created. Vi nginx.yaml. So kubectl create -f nginx dot, now kubectl get pods. Its container is getting created. It is also in running state now. If you see here, it is in the running state. Now kubectl get pods -o wide. You see Nginx is created. So now if I want to access this Nginx, we can use this IP. Okay, so I'll use curl if I execute curl this IP. If you see, welcome to Nginx page, it is displaying this Nginx page, right? Means it's confirmed that this pod is functioning properly in real time. Any application pods you deployed, so you are going to send API request to that application, whether it may be curl command. How we are going to test it, it depends upon that application. Okay, what kind of application it is, we can confirm. Okay, but here pods are not immortal. Okay, so they can die anytime. Pods will delete and new one will be get created automatically. So how you can achieve the high availability? See, the pod concept, pod.yaml component concept, initially they created, but how you are going to achieve the high availability? Here in the specifications file, cat nginx specifications file, in the specifications or in the metadata, you cannot define the replicas. Means you want to you want 3. Okay, so that it should be highly available. If one pod goes down, then another will come online. How it is possible? Like let's say if I want to create 2 pods, so even these 2 pods will get created in 2 different worker nodes. So if this worker node goes down, or maybe this pod is crashed, still application will be up and running because another pod is available inside the different worker node. But in the pod kind called object, here the kind object pod is there, right? Here you cannot define replicas. Okay, so you cannot define replicas. So it will not work if you define replicas. That option is not available. So you can create only single pod with this pod manifest file. So then how we are going to achieve that if you want to achieve high availability? So for that, Kubernetes introduced another kind object called replication controller. Okay, so they introduce concept called replication controller. So what is this replication controller? Replication controller, you can give replicas. So you can give 2 replicas, 3 replicas, multiple replicas you can give. So the main advantage of replication controller is high availability. So there you can see instead of pod, you can use kind replication controller. Okay. And before that, we can execute few more commands: kubectl get pods, you can see. And another important command is kubectl describe. This describe command is like a docker inspect command for inside the docker. Okay, same way. So kubectl describe the object name pod and the pod name. So you can see the information about this pod. Okay, from here, what is the name, under which namespace, okay, on which node it got deployed, and you see the CNI Calico network it is using, and the IP address of this pod, and from where the image has been pulled. Okay, so state it's running or it's any problem, and the memory and CPU resources, how much we defined. Okay, all these things, and the ready state, always it should be in the running, and this ready state should be there. Okay, and this the final this information will show in real time whenever you're deploying an application. Immediately it will not come on, and sometimes it will give error. So then you should go and check in with this command, describe command. So it's pulling image. Sometimes, for example, it cannot able to connect the repository. Let's say if it is an artifactory, JFrog or Nexus repository, there is an image is there, application image. So from there it should pull the image. So if it not able to pull, or if it not able to access, then here you can see the errors. Now unauthorized, or maybe the image you mentioned in the manifest file is not available. So if everything works fine, then only it will come in this way. It will pull the image, create container, and it will start the container. Then only your pod will show in running state. If anything happens, your pod will not show in running state. So this is a describe command. You can use it for the troubleshooting. Okay, and to get inside the container, I mean inside the pod. So if you see here, containers, you can see, right, containers, and this is a container name. Here I mentioned container name is this one, so that's why it is showing container name. This is the container name. If you define multiple containers, under this tab only you can see the second container name. This is first container information, and the down second container information will also be displayed here. So how to go inside a pod? If I want to go inside a pod and to see, so kubectl get pods to see the information, kubectl exec -it, same like docker command. So use the pod name bash. I am inside the container now. Okay. Now if you check here, this is the container, host name, memory demo. This is an container. But someone asked me just now if multiple containers are there. As of now, I'm logging to the pod. Pod contains only single container, so directly it went to that container. If your pod contains multiple containers, then you should use. You need to tell that in which container you want to log in. So you need to give -c container name. So that container name you can get it by this describe command. So you will get two containers. So in which container you want to log in. So you can use to that container. Okay. C container name, then you will log into that specific container. If only single container is there, you no need to give -c. Directly it will go and log into that single container itself. Okay. So now replica set. We talk about replica set. So replication pods. An RC will launch a specified number of pods called replicas and makes sure that they keep running. For example, when a node fails or something inside of a pod, that is one of its containers gone wrong. Okay. So replication controller will help you to achieve the high availability. Cat rc.yaml. So here I have a YAML file for a replication controller. Only simple thing it is changes kind is replication, and in the specifications field you can see replicas 3. If this option you cannot give inside a pod. Okay, so in the replication controller, this is a metadata information, means the name of this one replication controller, what are you creating, and this is a selector. We'll discuss about selector later on. And this is the specifications. Container, Nginx image, and port is 80 is we are using for that one. Same like almost pod specifications only. Only changes this one replicas here. Okay, and the kind replication controller. So now kubectl get pods, kubectl delete pod. I'll delete these two which are I created. Okay, it's done. Now we can't see. Now what I'm going to do, I'm going to create this replication controller. So kubectl create -f rc.yaml. Now kubectl get pods. 3 are getting created. 3 are in the running state. And now if you see kubectl get pods, -o wide. So these are the 3. So we have only 2 nodes. That's why 2 pods got created on one node and another one created on different node. Okay, see 232 IP, 232 IP, and this is 118 IP. So these 3 got created in 2 worker nodes because we have only 2 worker nodes. So you can achieve the high availability. Let's say what I'll do. Still, if you see 3 only, I deleted the pods which I created with the pod.yaml file, pod manifest file. It never recreated back. Okay. But in replication controller, if something happens to a pod or if something happens to a worker node wherever this pod is running, then replication controller responsibility is to maintain the value which is defined in the manifest file 3. Okay, so now what I'll do, kubectl delete pod. I'll delete one of the pod. Intentionally I'll delete this pod, and then see immediately it started creating another one. Okay, so immediately it will try to create another one because the replication controller, if you remember, control manager in the master's component. Okay, what the control manager contains: replication controller, okay, node controller, endpoint controllers with their controllers. So that controller's responsibility is to check the replicas value, whatever we define, it should maintain. Even if single node is there, single worker node is there, it's try to create all the three on that single worker node because its responsibility is to maintain the high availability, whatever the number replicas has been defined. Okay. So now again immediately it has been created the replication controller also. Okay. So this is how we can achieve high availability with the help of replication controller. Okay. So basically, yeah.
Here all the work, okay, so whatever we are doing, everything will be carried out by the worker nodes, right?
Hmm.
So
Yes.
what does, am I audible?
Yes.
Yeah. So I'm asking, so we are doing some, we are creating pods, replication, I mean, multiple pods, all those things. So each and everything, worker nodes will take care of it. So what does, a master node do here? So what is the role? Because we are running everything from master node. But how does, what is that role, master node's role?
Already we discussed that what master is doing. The master is having the components like node controller, the controllers, API, cube, etcd, the cluster status will be available, and whatever the command now I'm executing, kubectl delete pod get pods, first it is going to the API server which is inside the master, and API server directs what action needs to be taken. So if you are creating replication controller, then it will go to the control manager. From there, it will send it to the scheduler. Scheduler is also inside the master. So scheduler will go and tell to the worker node to create so and so pods inside this worker node. So all these things is doing by the master only.
Okay. So can we create any pods in the master node? Is it possible?
No.
Okay.
So, question. The
Hmm.
number of replica set that will be defined will be based on the number of node that is available.
No. Number of replicas will be decided after doing performance testing by your testing team. Okay. And yes, sometimes it will be worker nodes, sometimes it may be 5 10, but you don't require those many replicas over there, so you need only maximum 3 replicas, but you may have 6 to 7 8 worker nodes also will be there. So it's not based upon the worker node, but if your worker nodes are very less, if you have only 2 worker nodes, but still you can give 3 as in replicas. But if you have only one worker node, there is no use of giving 3 replicas until unless, see, first of all, why we use 3 replicas. One is high availability purpose. Major reason is high availability. So if any of the worker node goes down, your application will run from the another worker node. Okay. So it's not mandatory to have 3 worker nodes to use 3 replicas compulsory. But in real time, obviously, it will be always more than 3 will be there. 3 or more than 3, 4 will be there compulsory. So we can give 2 or 3 replica sets. Okay.
Hey, Praveen, quick question. When you kill that pod, it created a new one, but the IP address is changed. 90 initially, after that 91. So inside a pod, if there is an application, if there is a container contains an application, so does it impact anything or?
Yes, that is what I said here when I was discussing about a pod which was got created. These pods are not immortal. These pods are mortal. Like they can die anytime. They can even containers also. Why we call it a stateless application. So they will deleted and recreated. Okay. So whatever the IP using by this pod, the single pod. First, I created a pod. I accessed that pod with that IP address. So here now I am using replica set and it contains 3 replicas, and each time whenever I delete it, again it will get created and it will get new IP. Okay. So to overcome this, we will use a service called load balancer.
Okay.
Okay. So load balancer internally talks to this pods. Doesn't matter what IP it is using, it's changing. So load balancer IPs will be dedicated, and load balancer will internally communicate with these pods.
Okay. Yeah, the domain name will be pointed to
Yes.
that load balancer. Okay.
Yeah, load balancer will be configured inside the API gateway with the URL, and that URL is accessed, and internally that is going to communicate with these pods. That we'll discuss in the services class. I will talk about cluster IP, load balancer, node port, what is it, how we configure it. Okay.
Okay. Thank you.
So this is one by one, step by step we are coming. First we are creating a pod. So now if you say I mentioned 3 replicas, but how a customer can able to access this application now? Each pod is having different IP. So each pod contains same data, but we should access separately. So this is how we not use in the real time, right? So we need load balance.
Yes.
Load balancer will send traffic to this pods, and it will communicate with these IPs, and it will send traffic to this one. So that will those are separate sessions we'll have, and we not yet completed about this. Tomorrow we'll talk about little bit of more about replica set, and then we need to talk about as of now we are talking about replica set, and then we'll talk about stateful set, and then daemon set, and then deployment. Tomorrow this session will be completely on these topics. So as of now, still few more things are pending in the replica set, and then we'll talk about these things. How to deploy an application on different ways. So pod from pod to here. Okay.
Okay, sure. Thank you.
Okay, guys. Thank you. Thanks, everyone.